Okay, this is Mr. Peterson, and I'm going to go over the notes for section 2.4, part A. And this is an introduction to complex numbers. It might also be called Introduction to the Imaginary Number I. So we're going to learn about that number you might have heard of in fables and myths, but you're going to learn about the number I in this note set. But first, we're going to start with some real numbers, the ones you are used to. And we're going to start with the square root of 36. That's equal to 6 because 6 times 6 is 36. Now, a word of explanation here. This radical sign, it looks like a little check mark with a roof, that sign there. If there's two answers, it'll only give the positive answer. You'll notice that 6 times 6 is 36, but negative 6 times negative 6 also gives 36. Your calculator, which uses that radical sign, will kind of show you this and illustrate this. It only gives you the 6 answer, even though 6 times 6, that answer works, but negative 6 times negative 6 also works. So the radical sign is the positive answer if there's a choice. Okay, so 81 is a perfect square. It's a square root of 81 is 9, and that would be because 9 times itself is 81. Square root of 49 is 7, since 7 times itself is 49. And these numbers that have easy square roots are the numbers you would find on the diagonal of the multiplication tables that you learned in elementary school. So let me kind of remind you of that. You learned all the way up to 12 times 12, but this little piece of sticky paper here doesn't have enough room for me to go that high. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. These are called the perfect squares. And so when you square root this number here, you get 4. So the square root of 16, like this, is 4. That's the opposite of squaring 4. Okay, so the perfect squares list, the ones that turn out to be whole numbers when you square root them. 2 times 2 is there, 3 times 3, and so forth. Here's the last one here is 8 times 8. 9 times 9 is 81. 10 times 10 comes next. 11 times 11 is 121. 144, and most students stop there in elementary school, but you can keep going. 13 times 13, 14 times 14, and 15 times 15, just to extend your knowledge a little further. Okay, and then the ellipsis means this set of perfect square numbers goes forever. You really aren't going to ever finish that list. For instance, 900 would be out there. That's 30 times 30. Okay, now most numbers aren't perfect squares. If you look at the square root of 48, you know that 6 times 6 doesn't give 48, so that's too low. That'd be 36. And 7 times 7 is a little bit too high, so it's between 6 and 7. So let's find out the decimal approximation. You'll hit the second key, and the square root's about 4 or 5 down. Type 48, and you get 6.928 if you round it off. So if you take 6.928 times 6.928, in theory, you'll get something like 48. So let's try that. 6.928 times 6.928, and you get something very close to 48, but not exact. So the squiggly equal sign means it's approximate, and sometimes there's a dot above an equal sign, which means the same thing. So you can see that mathematicians who like precision don't really like the decimal versions as much. And what you're going to do instead is break up the square root and simplify it. You may have done a little bit of this in geometry, but I'll show you how to get this done. So what you want is a perfect square that goes into the number. So 48 is a multiple of 4, namely 4 times 12. And then the square root of 4 is an easy number. It's just 2, so there's 2 root 12. You're going to see a better way to do it down here in a second. The problem with this is it's not finished, and you have to keep going, and many students don't recognize that there's still a perfect square inside that 12, namely another 4. So square root of 4 times 3 is 12, and that square root of 4 comes out as another 2. Which then, when you combine with the one we already got, gives us 4 times the square root of 3. And that's your final answer there. However, the better way to do this is to take out the biggest perfect square you can. Sorry, my speller's a little broken there, but biggest perfect square, and the biggest number that's a perfect square that goes into 48 is not the 4 we tried last time, but the 16. You want the 16 to come out of it. And the square root of 16 is just 4, so you can see how I simplified that. Now I'm going to let you use your calculator on this and show you how to break that up. So what you can do is go to the y equals key, and let me clear out some of the old junk I had in there. 48 divided by x will display the factors of 48. So now you go second table settings and make sure it's set on 1 for the start value, automatic mode down here. Then you go to your table, and you always want to cruise down the right hand side because you want the biggest number, and there's where the big numbers are over there. You're looking for a perfect square. 48 doesn't qualify. 24 is not a perfect square. But 16 is in the list, and it's the first one on that right-hand side. So 16 times 3 is the best way to break this up. And our final answer here is the same as we got before, but with a whole lot less work and truly a lot less danger, because many students are in danger of getting this wrong for not finishing when they get here. All right, and that does it for page 1 of the note sets for sections 2.4a.